Mic test 1, 2. Awesome. Thank you for bearing with me here. I'm still learning a little bit how exactly these live streams work using the OBS software, which I talked a little bit about yesterday. Live streaming from Zoom, I find to be very, very simple, and I am very, very comfortable there. Live streaming from OBS, slightly different story, but that's okay. I'm working on this. As you can see, I made a little holding screen that says 6:30 p.m. the current time. I have is 6:39. All right, 9 minutes behind, but that's okay. That's all right. I'm back today to share with you my thoughts on Scratch. If you've never heard of Scratch, it is a online programming interface developed by MIT that I really love. I can't say enough about. I didn't always, I will admit. At first, it was a little bit tricky for me to pick up. So teachers don't feel ashamed if it feels hard or feels weird or doesn't, isn't clicking, or the kids are getting it faster than you are. I say hang in there, because it really is like programming. And sometimes it's just hard. And I think part of what we're trying to teach them is, how do you work through that? Like when something gets hard, do you just stop? Do you give up? What are some ways of working through that? Because I think, as a lot of us have experienced, there is great satisfaction in solving some of these problems on our own and being a little bit more self-sufficient. So hopefully, we can guide our students and lead them in a path that is going to let them feel that challenge, that struggle, but that success and that reward when they come out on the other side and have a solution that works and is theirs. So that is my sort of grand philosophy of Scratch is, I hope it's an empowering educational tool that has students asking questions. How do I make this happen? And then figuring out how to program that and how to make that happen. So without further ado, let's see if I can share with you Scratch. And I want to share that one. I apologize, I'm not too attentive to the chat, and you'll have to bear with me on that. Okay, so I'm gonna try a little different setup for today. Let's see how this goes. What's cool about the OBS software, while I dilly-dally here and get myself prepared, is it lets you kind of prep screens and prep scenes and change stuff up in a pretty unique way. So I'm like prepping my stage on one side and getting my videos ready here. And I don't want to take up too much room here. I'll just be off in the corner so that way we can sort of see what's going on. Oh, that's Gigi in the background. Don't mind her. Maybe she'll come over and say hi a little bit later. My faithful guard dog, Gigi. Okay, so this is the Scratch homepage. If you just type Scratch into any search engine, probably it'll be the first thing that comes up, but the website is very easy to remember. It's just scratch.com. addons.mit.edu. And so here we are, the glorious homepage. I do recommend joining Scratch and creating an account and saving your projects. You can work without creating an account. So, if you ever are just want to try something out, want to see how it works, sometimes the account creation process can be a little bit painful. So if you just want to get your toes wet or just want to try, an hour code, 1 hour activity with your students, they do not need to create accounts to get started, which is one thing that I love. The other thing that I love, number 2, are these ideas. Some of them are featured up here, and these are some of their kind of preset hour of code activities. The Imagine a World, code a cartoon, using some characters from Cartoon Network, and the Make It Fly tutorial. Any of these, I think, are brilliant starting places. I have my own set of preferred tutorials to go through, and where I like to start is indeed with the Getting Started tutorial, and you can see more over here on the Ideas page. What is awesome about these tutorials is when you click the button to try it, it's going to open up a page with this little window here that you can drag, drop, move around, shrink, expand. This video here is great. I encourage the students to watch it. Sometimes I watch it with them. Sometimes I share my sound. Sometimes I do my own little voiceover narration. But I do like to let these videos play so that you get an idea of what that project is going to be like. They'll do some of the steps, but not all of them. And so when you're done with this video, you can go ahead and click here to go on to the next step. And at this point, I usually walk through it little by little and answer any questions, but they're off to the races. It's very hard to hold back certain students when they get to this point. It's very easy for them to see what they need to do and get this done. And especially if they have any familiarity, they'll know exactly what's going on. So once they're done and they get to the final page, it always gives suggestions of other things you might like to try. So after the Getting Started tutorial, I usually recommend that you add a backdrop. It's a little bit plain without it. Then I recommend trying to add another sprite. And so my first day's activity, we're just setting up a scene. We're doing basic interactions that are triggered when the green flag is clicked. Once I think they've got a basic handle on these tutorials, I really love this one here with the pink balloon or the pink background and the yellow and blue balloons. This Make a Clicker game is so satisfying. It's fun, it's interactive, and usually the kids know, oh, I know what clicker games are. I can do that. Again, very simple, begins with the video. Has these great tutorials that show you exactly what to do. And they use balloons in this. I think when I taught it, sometimes I do the balloons, sometimes I don't, sometimes I change it up. But as a teacher, so long as you go through the tutorial, you're going to be fine. If you can go through the tutorial, you'll be able to guide them through the tutorial. When it gets to debugging, I always encourage or incentivize other students. Can anybody else find this problem? That'll give students that are working ahead a chance to kind of slow down and think and look and practice their debugging skills, while sometimes getting you off the hook. Sometimes the problems that are created in Scratch aren't always clear, and it's not very easy to just know all the answers all the time. Sometimes you need to rely on other students or other people, and I think that's great, and I think it's part of the learning process, and I think those students feel so proud when they kind of outdo you. After the clicker game, I usually go into one of the story ones, either the Coda Cartoon is fun. There's a couple of these in here. I also really love Make Music. Where are you? It's got a guitar. Here we are. The reason I like the Make Music block is because I believe that having the auditory component when teaching repeats and teaching loops really helps students grasp and understand that. You know, sometimes when they're creating a repeat loop, it's hard to see, well, I put in 5 or I put in 50, but I can't tell what's happening. Is anything happening? You know, depending on the interface. But if you tell a note to repeat 5 times or tell that note to repeat 50 times, you're definitely going to hear that difference. And I think it gives them a little bit better appreciation. If you are interested in learning more about Scratch, the Scratch tutorials, I actually have a number of them pre-recorded for CS as elementary and for Code 5. In fact, let me, I'll bring up my props here and give a shout out. Over the summer, I worked with them. We put together a 10-day project that lines up a bunch of these tutorials in a meaningful way that is intended to give students mastery and autonomy over these basic concepts like a variable, user inputs, interactions, so that they can, you know, be creative and not just follow tutorials, but, you know, think of things or remix other things and really have an understanding of what's going on. We'll link to the Infosys Pathfinders Online Institute, where you can get all the details about those Code 5 lessons if you are interested in that. I really recommend it for very first time Scratch coders or teachers trying to get their feet wet. The next tool that some of you are probably familiar with that I love and highly recommend is the Google CS First Scratch curriculum. Is csfirst.withgoogle.com. That is the one that I always like to use for my logins. So again, I will share this with all of you. It is currently loading. All right. So as you can see, a free computer science curriculum that makes coding easy to teach and fun to learn. And I genuinely believe that this is true. We use this curriculum all the time with STEAM coders. It's one of my go-to. It's one of my favorites. I'll give one more shout out here. Whoop, whoop, STEAM coders. All of our staff are trained with it. We all use it. We all love it. The surveys are outstanding. Good stuff. So highly, highly, highly recommended. Let's dive in. So as a teacher, again, you do not need any special fancy account. So you can be a nonprofit, you can be an individual. It does not matter. Again, I love that you don't have to have like a .edu or the state school account in order to participate in this. And very similar to CodeSpark, we kind of get this login screen. So teachers, students, it doesn't matter. You can all start in the same place, all click sign in. Students typically log in using a classroom code or a special link that you can send to them. You as a teacher are just going to go ahead and log in with your email. I'm going to log in with my STEAM Coders email. It's a little bit more interesting. I've got some more action going on there. And this little OAuth, we do a little redirect. while we're waiting for this to load up here, the curriculum is divided up into 3 sections: beginning, intermediate, and advanced. They also have standalone one-day activities. So most of the curriculum sets do take about 10 weeks to complete, more or longer, depending on, how you as a teacher are utilizing it. The add-ons, it could go the full semester or longer. So here you see a couple of classes that we have done lately. And as the program manager, I like to set up all the classes for all of our instructors. And then I'm able to invite my fellow staff as co-teachers to help manage that classroom. And each classroom has a unique classroom code that allows students to log in. So I will, let's see, what should I pick from? I love my ACAM school, my ACAM kids. Let's take a peek inside here. So they were working on music and sound, which is one of the beginning and introductory curriculum. You'll see here we had 16 students enrolled in this class. And another feature I really enjoy is in real time, when students log in and are looking at the lessons along with you, you can see exactly how many students are signed in. So obviously we're not in class right now, so I'm not expecting anybody to be signed in, but if they were, I would be able to see that in real time. We had obviously here, a lot of students completing this first project, these first few projects, and it's pretty typical to have some attrition. I don't know what exactly happened here. This chart doesn't look awesome, but that's okay. Go in and figure out what's going on. Sometimes what happens, they do assign these CS and number accounts, and sometimes the kids do not remember what they are, and they have their own personal Scratch accounts. And so they just start making all of their projects in their own personal account. So then it's not getting tracked in the system. So it's a good tool, but you have to make sure that they're logging into Scratch with their Google CS First account that they were assigned and created. And the username is usually CS followed by a string of numbers, and the passwords are, I think, randomly generated, or maybe not. Maybe they can set them. But either way, it's usually the username that's hard to remember. You can keep track of it as a teacher. So if this type of progress and alignment to the standards and that type of reporting is important to you, make sure to keep really good track of your students, their account numbers, and make sure they're logging in and submitting those projects. But let's take a look inside the music and sound curriculum. The ACAM school, like I said, it's a music school. So I'm hoping that they turn in some final projects this week with some of their own music recorded in. We will see. Thursday is their last day of class. And I can't wait to see their final projects. So they have done all 8 activities in this lesson. And as you can see, it's about 8 to 12 hours. They say here, 45 to 90 minutes each, because oftentimes they have, this one does not, but they have these add-ons. And so what we're looking at here is the overview for the lesson. And if you click start, it'll walk you through in a slideshow fashion, beginning with the survey, going into a video. Anytime you see the play button, that indicates this is going to play a video to help teach. So overview of Scratch, another video for the intro to computer science, another video for programming something unexpected, which is the first project. After they've watched this video, they are turned loose to create that project. The reflection, anytime you see these charts, that's another little survey. And the wrap up are usually additional activities, things to talk about, of course, sharing your project, showing your project, etc. Here, this is fun. When you see that little puzzle piece block, that is an add-on. And add-ons give students a number of different options to pick from in terms of how do you want to customize your project. Yes, here's the base project and here's like the bare minimum of what we expect you to do. But here are some ideas for going above and beyond. So this video is going to explain to us what add-ons are. And as you can see down here, choosing an add-on, a bunch of options. So invite friends to join the dance party. Do you want to add more sprites in, basically? Add and change the backdrop. So maybe as she's dancing, she could move towards the edge. And when she hits the edge, it changes into a new scene. Make it look like she's doing the twist. Make it, maybe look like she's going back and forth. Is that using the flip, the rotate? Are we customizing sprites? I'm actually not sure. I haven't done all of these add-ons. And again, you as an instructor, I don't think you need to. If you go through the basic lesson, let the students explore the add-ons, and as they run into challenges, difficulties, encourage them to help each other and learn along with them. I think teaching computer science just requires being honest, being humble, being willing to learn, and so long as you have those qualities, you're gonna be fine. So let's just take a quick look at some of the other curriculum sets before I sign off for today. So here you can see the 1 hour activities. So if you're looking for an hour of code activity, these are perfect. Any of these would do. If there's one that tickles your fancy, I say go for it. But they are all very similar. You can see they have ratings, introductory, intermediate, etc. These are the recommended hour of code ones here. You can see they're sort of picked out, but of course, any of the 1 hour activities would be fine. The multi-day activities, let's say, your hour of code lesson goes wildly successful. Here's where you can really dive in. So, in the winter and spring semester, you can come in with these 8 to 12 hour lesson plans. And tons of resources for teachers as well. I'm going to show you just quickly the materials page here. Again, does have solution sheets, just like in CodeSpark. If you really get stuck and you really don't know how to make something work, this should give you at least the bare minimum to get the job done. Now, there's always more than one way, and if somebody comes up with a creative way, so long as it works, that's okay. Just like, Gracie in CodeSpark, whether she's gonna walk forward, or hop, it doesn't matter. It's all the same. She gets to the end, and that's good. There is definitely more than one way to solve these problems. These lesson plans also are excellent. They've got connections to standards. They've got it broken down line by line. So even if you needed a script to read, that's here for you. Exactly what to do. I love this here. So yeah, have students log in to their CS First accounts. Great. Have students watch the video. Check in with the students. Questions to ask. What was your favorite part of the activity? What story did you tell? What blocks did you use? What did they do? It's so helpful. And it just goes lesson by lesson, video by video. So that's kind of what I got for you guys today. I will also put a link to the Google CS First website alongside the Pathfinders Institute. But I can't say enough just for needing to be creative, needing to explore on your own, getting stuck, working through it, trying new projects. If you can go through it and if you can do it, I guarantee you your students will have fun. And even if you can't, maybe it's an opportunity to get them started and maybe they could help you out. The video tutorials in this make it very, very simple to teach. You do not need to do a lot of preparation on your own, although I do recommend, having a general idea of what the content is going to be about. That is all I have for today. I will be back tomorrow at about the same time. And we will kind of look at the next level of programming. We're going to start to look at a typed programming languages. Excuse me. There is a sort of great intermediary tool called Code Combat. There is some free resources available, some licensed resources available. So depending on, your budget and your level, it might be a good gateway stepping stone, or it could be, the perfect asset for your computer science curriculum. So tomorrow we will take a look at Code Combat and how to get kids transitioned from the block programming languages to the typed programming languages. Thank you all for tuning in. If you have any questions, you can always reach out, put them in the comments. I'd love to hear them.